everyone, in this video we're going to look at data access. So to send data to get from the source to the destination, we need two types of addresses. One is the network layer source and destination address, which is basically the IP address. Then at the data link layer, we need the physical address. So at layer 3, the logical address is basically the IP address. We need the source IP address to indicate the sending device and the destination IP address to indicate the receiver. So these addresses may be on the same link or network, or they could be on remote networks. So an IP address contains two parts. The first part is the network portion, or in IPv6 we call prefix. So this network portion indicates whether a particular address is in the same network as the sender or in the remote network. If the two addresses are on the same network, that means the network portion will be the same. The second part of the IP address is the host or interface ID address. This address should be unique for each device on the network. Let's look at the usage of the addresses when a sender wants to send a packet to a receiver that is on the same network. So here we have an example. PC1 wants to send data to the FTP server. Let's assume that the IP address for PC1 is 192.168.1.110, while the FTP server is 192.168.1.9. So this is a class C address with a subnet mask of /24. So that means the first 24 bits will be the same if these two addresses are on the same network. And in this case, they are, because the network address is the same, which is 192.168.1. So let's look at the packet here, the source and destination IP addresses. So on the network portion, it will be 192.168.1. Also for the destination, 192.168.1, while on the host, they will have individually unique addresses. So since they are on the same network, they do not need to be forwarded to the default gateway. So in this case, the switch here, they will use the exact or the actual network interface card or the physical address for each of these machines. So let's assume the physical address for PC1 is all A's and the physical address of the FTP server is all C's. So when you want to encapsulate the header at the data link layer, they just will put the actual physical address. Now let's look at another example where the source is PC1 and the destination is the web server, which is connected to a different network or a remote network. In this example, the IP address of PC1 is 192.168.1.110, while the IP address of the destination or the web server is 172.16.1. Okay, so we can, at first glance, we can already assume that they are on a different network because the network portion of the IP addresses are not the same. So when we need to send a packet to a different network, it needs to go through a layer 3 device. In this case, it is a router. Okay, so this router here, router 1, acts as the default gateway for this network, the network of 192.168.1, while router 2 is the default gateway for the network 172.16.1. So the default gateway is the door or the gateway to all other remote locations. So you need to send your packet to the router. In this case, the data link layer or physical address that is used in the packet will not be the actual data link layer address, because PC1 ni, there's no way of PC1 can know what the physical address of this server because it's on a different network. right? So when the router receives the packet, what it will do is it will address this data link layer header to the addresses that is actually on the same network. So PC1, first when it needs to send to a different network, it will just find the MAC address or physical address of the default gateway. So in this case, the MAC address is 1111, all ones. So this is the process of changing the physical address. So the first phase is the PC1 will put the destination physical address as the interface of the default gateway. Next, once the router receives the packet, it will look up the routing table based on the destination address of the server, and dia find out yang dia akan forward kepada this router. So what it does adalah dia tukarkan source dengan destination physical address daripada source address of PC1 kepada source address of this interface. And destination physical address daripada this interface kepada the interface of the next router. And then finally, bila sampai dekat router ini, router 2, since the IP address is on the same network as this router, dia akan gunakan the MAC address of the web server, and the source address at the data link layer is the physical address of this interface of the router. Jadi di sini kesimpulannya, source and destination IP address tak akan berubah, tetapi source and destination physical address akan berubah dari satu hop ke hop yang lain. The layer 3 addressing remains the same because it is a global address. It's end-to-end daripada sini sampai ke destinasi. Okay. Tetapi dekat frame or the data link layer punya protocol data unit, the addresses will change based on the network interface card address that is concerned. Daripada sini ke sini, satu segmen, satu local area network. Sini ke sini adalah satu segmen, and sini ke sini adalah satu segmen. So that's it for the data access.